So we've seen finite Herbrand logic is very well behaved. All questions are decidable. With omega Herbrand logic, we can say more. Admittedly, we lose decidability, though we retain semi-decidability. What happens when we relax our restrictions and look at general Herbrand logic, GHL? That is Herbrand logic without any restrictions whatsoever. Good news about GHL is that it's highly expressive. We can formalize things in GHL that cannot be formalized, at least not in finite form, in the other subsets we've looked at so far. For example, in an earlier segment, we showed how to formalize addition and multiplication in finite form. It's not possible with restricted forms of Herbrand logic, like FHL and OHL, and it's not possible in other logics, such as first-order logic. The bad news is that the question of unsatisfiability for GHL is not even semi-decidable. Explaining this in detail is beyond the scope of this course. However, we can give a line of argument that suggests why it is true. The argument reduces the question of decidability, of satisfiability, logical entailment, and so forth for GHL to a question as broadly accepted to be undecidable. So if our logic were decidable, then this other question would be decidable, and since it's known to be undecidable, logical entailment for GHL must also be undecidable. Okay, as we know, Diophantine equations can be readily expressed as sentences in GHL. For example, we can represent the solvability of the Diophantine equation 3x squared equals 1 with the sentence there exists an x such that x times x is, there exists an x and a y such that x times x is y and 3 times y is 1. We can represent every Diophantine in an analogous way. And we can express the unsolvability of a Diophantine equation by negating that sentence, saying there does not exist such an x and a y. We can then ask the question of whether the axioms of arithmetic logically entail this negation, or equivalently, whether the axioms of arithmetic together with the unnegated sentence are unsatisfiable. Problem is that it's well known that determining whether the natural Diophantine equations are unsolvable is not semi-decidable. If we could determine the unsatisfiability of our GHL encoding of a Diophantine equation, we could decide whether it's unsolvable, contradicting the non-semi-decidability of that problem. Note that this does not mean that GHL is useless. In fact, it's great for expressing such information. And as we'll see, we can prove many results, even though in general we cannot prove everything that follows from an arbitrary set of sentences in Herbrand logic. We're going to discuss this issue further in future lessons.